Hey there, science fans! Today, we're diving into the fascinating world of a kitchen staple, the microwave oven. This incredible invention has revolutionized the way we cook and reheat food, offering unparalleled speed and convenience. But have you ever stopped to wonder about the science behind this magical box? How does it heat food so quickly without a flame? Let's unveil the mysteries of the microwave oven together. Our story begins not in the kitchen, but in the realm of wartime technology. The microwave oven, a staple in modern kitchens, has its roots in the intense and innovative period of World War II. It was a time when technology was advancing rapidly, driven by the needs of the military. During World War II, an American engineer named Percy Spencer was working with magnetrons, devices that generate microwaves for radar systems. These magnetrons were crucial for the development of radar, which played a significant role in the war effort by detecting enemy aircraft and ships. Spencer was a self-taught engineer, known for his curiosity and problem-solving skills. One day, while standing near an active radar set, Spencer noticed something peculiar. A chocolate bar in his pocket had melted. This unexpected event sparked his curiosity. He wondered if the microwaves from the radar equipment could be harnessed for other uses. Spencer began experimenting with different foods to see how they reacted to microwave energy. Intrigued, he experimented further, eventually leading to the invention of the first microwave oven, the Radarange, in 1945. The Radarange was a large, bulky machine, quite different from the compact microwaves we use today. It was initially used in commercial settings such as restaurants and ships, due to its size and cost. Talk about a happy accident. Spencer's serendipitous discovery revolutionized cooking, making it faster and more convenient. Over the years, the technology was refined, leading to the affordable, user-friendly microwave ovens that are now a common feature in households around the world. This story is a testament to how curiosity and a bit of luck can lead to groundbreaking innovations. At the heart of every microwave oven lies the magnetron, a small but powerful device that generates electromagnetic waves called microwaves. These waves are a type of electromagnetic radiation, similar to radio waves and light but with a shorter wavelength. The magnetron uses electricity to create a high-voltage electric field which causes electrons to move rapidly. This movement generates microwaves, which are then channeled into the oven cavity. Now here's where the real magic happens. Microwaves have a unique ability to interact with water molecules. You see, water molecules are polar, meaning they have a positive and negative end. When microwaves penetrate food, they cause these water molecules to vibrate rapidly, rotating billions of times per second. This rapid movement generates friction between the water molecules and their surroundings, producing heat. This heat then spreads throughout the food, cooking it from the inside out. Section 5, Microwaves versus Ovens, a tale of two heating methods. In today's modern kitchen, we often find ourselves choosing between the convenience of a microwave and the traditional reliability of an oven. Unlike traditional ovens, which heat food through convection and radiation from the outside in, they provide a more even and thorough cooking process. The heat circulates around the food, ensuring that it is cooked uniformly. Microwaves, on the other hand, heat food directly by exciting water molecules within the food. This method of heating is fundamentally different and much faster. This is why microwave cooking is generally much faster. A dish that might take an hour in a traditional oven can often be ready in just a few minutes in a microwave. However, it's important to note that microwave heating can sometimes be less even than traditional oven heating, especially with thicker foods. This uneven heating can result in hot and cold spots within the same dish. This is because microwaves penetrate less deeply. They tend to heat the outer layers of food more quickly, while the inner parts may remain cooler and may not reach the center of thick foods as effectively. This can be particularly problematic with dishes that have multiple layers or are very dense. Traditional ovens, with their ability to maintain a consistent temperature and circulate hot air, excel in cooking larger and more complex dishes. They are ideal for baking, roasting, and slow cooking, where even heat distribution is crucial. Microwaves, however, are perfect for quick meals and reheating leftovers. They offer unparalleled speed and convenience, making them a staple in busy households. Ultimately, the choice between a microwave and a traditional oven depends on the specific needs of the cook and the dish being prepared. Both appliances have their unique advantages and can complement each other in a well-equipped kitchen. Section 6. Choosing your vessels. The importance of microwave-safe containers. Not all containers are created equal when it comes to microwaves. Using the wrong type of container can lead to melting, cracking, or even dangerous chemical leaching into your food. Microwave-safe materials such as glass, ceramic, and certain plastics are designed to withstand the heat and energy of microwaves without posing any risks. Always look for the microwave-safe label on containers before using them in your microwave oven. Section 7. The turntable's tail. Ensuring even heating. Ever notice that spinning plate inside your microwave? That's the turntable, and it plays a crucial role in ensuring even heating. As the turntable rotates, it exposes different parts of the food to the microwaves, preventing hot spots and cold spots. Some microwaves also feature rotating antennas or wave stirrers that help distribute microwaves more evenly throughout the oven cavity. Section 8. Power and precision. Decoding microwave settings. Microwaves come with various power levels and settings to accommodate different cooking needs. The power level determines the intensity of the microwaves, while the settings offer pre-programmed options for common tasks like defrosting, reheating, and cooking specific types of food. Lower power levels are ideal for defrosting or melting delicate foods, while higher power levels are suitable for cooking or reheating denser foods. Section 9. Safety first. Protecting users from microwave mishaps. Microwave ovens are equipped with several safety features to protect users from potential hazards. The most important of these is the door interlock mechanism, which prevents the oven from operating when the door is open. This ensures that microwaves are contained within the oven cavity and cannot escape to harm users. Additionally, microwave ovens are designed to prevent overheating and potential fires through various safety mechanisms. Section 10. Beyond heating, exploring the versatility of microwaves. While we primarily associate microwaves with heating food, they have a surprising range of other applications. Did you know that microwaves are used in telecommunications, radar systems, and even medical treatments? From transmitting signals across the globe to detecting speeding cars, microwaves play a vital role in numerous aspects of our modern world. Section 11. Conclusion. Appreciation for everyday science. So the next time you pop some popcorn or reheat your leftovers in a microwave, take a moment to appreciate the incredible science at work. The microwave oven, a staple in modern kitchens, is more than just a convenient appliance. From the ingenious invention of Percy Spencer, who discovered the heating effects of microwaves by accident, to the fascinating interaction between microwaves and water molecules, which causes the food to heat up, the microwave oven is a testament to human ingenuity and the wonders of physics. Imagine the countless experiments and trials that led to this everyday marvel. Stay curious, my friends, and never stop exploring the science behind the everyday marvels that surround us. Whether it's the chemistry of baking, the physics of boiling water, or the biology of fermentation, there's a world of science in our kitchens waiting to be discovered. So next time you use your microwave, remember the journey of innovation and curiosity that brought it to your countertop. Embrace the wonder of everyday science and let it inspire you to look deeper into the ordinary things that make our lives extraordinary.